GM everyone. Good evening, good morning, good night, whatever you are in the world. We know this is a worldwide hackathon, so definitely drop in the chat where are you seeing us from because this is a huge community. So we love seeing where you guys are plugging in from. Welcome to the second week of Block Magic. Man, it's going fast. And right now we have with us the only Patrick Collins from Cyphren. And he is going to show you how you can build tokenized RWAs or real world assets. And yeah, with that, I'll hand it over to you, Patrick.
All right. Thanks so much. GM, what's going on, everybody? How we doing? I can see all the chats going on here. We're going to build some tokenized RWAs. We're going to have a good time here. We only have an hour, so I'm going to have to teach you guys a lot of stuff real quick, but we're going to go over some really cool stuff. I have a video coming out on this as well, both on the Chainlink YouTube and on my YouTube, so be sure to look out for those because they're coming soon. I have a link I'm going to share with privately if you want to. Could you share that? Oh, that works too. Actually, yeah, here it is. This is on my GitHub repo, RWA Creator. This is what we're going to be building today. This is what we're going to be working with. And we only have an hour, so I'm probably going to take some shortcuts. But the beauty, the fact that this is live, is I want you guys to ask lots of questions if we get confused, if you don't know what's going on, etc. So I can see all the comments. Hello from Brazil, Houston, GM, the Solidity tutorial guy from like 10 years ago. Damn. GM from India, Argentina. Awesome. Cool. So this is the repo that we're going to go over. And I want to go kind of quickly just to show you what the final project is going to look like. And then we're going to go over kind of where actually I'm going to poll the audience, see which version you guys want to make. And we're going to go from there. So RWA Creator, this is the repo. You can see it, Patrick Alpha C, RWA Creator at the top. At a high level, we're going to go over, this project, a high level, what the end product looks like. Then we're going to let you guys vote on which version of this you want to see. And then we're going to build it with whatever remaining time we have left. There's a good chance we're not going to be able to finish. We're not going to be able to finish building the whole thing, but we're going to get as far as we can. Or I might take some shortcuts just so we can get to the end goal. So first off, a little bit of a backstory here. What is an RWA? And before we even go into what an RWA is, let's even take a further step back. What the hell is a tokenized asset? And the reason I want to start there is because there's a lot of information out there from very non-technical people telling you what a tokenized asset is, but don't worry, Mr. Froggy Patrick here is going to give you the real rundown, okay, of what's required here, okay? So first off, asset location, okay? What asset are we tokenizing? It can be either on-chain or off-chain, right? And so I have some fun little nomenclature, A on or A off. But that's the first thing we want to look at. Whenever we are doing a real-world tokenized asset, the asset is off-chain. That's it. That is a tokenized real-world asset. It's any asset in the real world that is off-chain that we want to turn into a token somehow, right? So that could be like your car, your house, a stock, a bond, your cat. I don't care. You can tokenize whatever you want for the real world, and that is a tokenized real-world asset. What it is not would be like a tokenized Ethereum, Bitcoin, Shiba Inu, whatever. Those are all on-chain assets. So by definition, if they're on-chain, they aren't real-world assets. So that's it. Does that make sense? Let me know in the chat if that doesn't make sense. So when we are talking about tokenizing real-world assets, we're talking about taking some tangible thing from the meat space, if you will, and turning it into a token. It has to be off-chain for it to be considered a real-world asset. Good, great. Moving on. So then the question is, okay, Patrick, but how do I tokenize my off-chain asset? How do I tokenize my house? How do I tokenize a stock? Well, this is where the next two pieces of methodology are incredibly important. You have the collateral location, and then you have the backing type. And this is where it gets a little bit tricky here, but just stay with me, okay? So your collateral can be either on or off-chain. So let's say you want to tokenize your house, or even simpler, let's say you want to tokenize a Tesla stock, right? The Tesla stock is considered an off-chain asset because it is off chain. If you wanted to tokenize the Tesla stock, you could collateralize it. You could back it with Tesla stock, right? And that would mean your collateral is off chain. So if you have a tokenized Tesla stock that's collateralized by tokenized Tesla, or excuse me, that's collateralized by actual Tesla stock, the collateral is off chain. However, and here's where it gets a little bit funky, you could also collateralize your tokenized Tesla with Ethereum, with USDC, with whatever you wanted. And that's where it gets weird, right? And this leads us into this next bit. And if that's confusing, don't worry. Hopefully it'll make sense in a second. That leads us into this next bit, which is the backing type. Your tokenized real world asset can either be directly backed or indirect, aka synthetic, right? So if you have tokenized Tesla that's backed by Ethereum, you would say that that is indirectly backed. Your tokenized Tesla is not actually backed by real Tesla stock. It's being backed by Ethereum, right? So it's indirectly backed. If your tokenized Tesla is actually backed by Tesla stock, you would say that that is directly backed and it's not synthetic. And that might be a little confusing, but let's go through some examples, and hopefully it'll make more sense here. So if we have an asset, actually, let me go through a better one. A classic stable coin is DAI. So stable coins are phenomenal examples of real world assets, right? Because all stable coins, the real world asset is the dollar, and then we have some token that represents the dollar. So let's look at a simple example here. DAI. So DAI is a pretty popular stable coin. It's an example of a tokenized real world asset. The asset itself that it's representing is the dollar, so it's an off-chain asset. The collateral, though, is on-chain. You deposit Ethereum into the DAI system, and it mints DAI. So the collateral is on-chain, like Ethereum or other currencies, and it's indirectly backed, right? It's synthetic because the DAI token isn't actually backed by dollars in a bank account. It's backed by Ethereum. Let's look at another stablecoin, USDC, right? This is a little bit simpler to understand. The dollar is the off-chain asset, and Circle has dollars in a bank account. And what Circle says is Circle goes, hey, at any time you can exchange your USDC for $1, right? So the collateral is off-chain. It's directly backed. The USDC token is directly backed by dollars. It's directly backed. Boom. We now have a tokenized real asset that has off-chain collateral and is directly backed. Another, so these are all examples. There's some more examples in here if you want to check them out. The question then is, okay, Patrick, like maybe you're unfamiliar with DAI, for example. You're like, Patrick, that sounds ridiculous. How could a tokenized dollar not be backed by dollars? That sounds insane. What do you mean it's backed by Ethereum? What the hell? And we have an example of this in this repo, in this RWA repo. If we go up to SRC, we go into S Tesla. This is an example of a synthetic Tesla token, right? And it uses Chainlink price feeds to actually ensure the price of the synthetic Tesla token is always equivalent to Tesla, even though this Tesla token isn't backed by Tesla stock, which sounds bizarre, I know, but here, let me scroll down to the main mechanism. This redeem and burn function, what it does in here is basically if you have one Tesla token, you can redeem it for its value in Ethereum. And that's how it keeps its peg. That's how it keeps its value. So even though it's not actually backed by, can basically sell it at any time for its value in Tesla underneath, right? So it sounds really bizarre. Hey, it's not actually backed by Tesla. What the hell? But this synthetic asset is actually a really, really common type of DeFi primitive in Web3, right? So some people are saying, hey, like do the house example, do the car example. What about those? Well, let's go back. Because those are actually great questions. I actually love those questions. So let's say you want to tokenize your car. Well, there's a couple of ways you can think about it. So the car itself is an off-chain asset. So let's scroll down to this method. As long as you just remember this methodology place, you can basically tokenize anything, right? So the car, is that an off-chain asset? Yes. Okay, great. It's an off-chain asset. Okay, what are you going to back it with? So if you're going to back your tokenized car with your car, okay, great. The collateral is then off-chain and it would be directly back. Now, the question then is, okay, well, how does my token reflect the value of my car at all times? Well, that's where you go, okay, we're going to have some centralized intermediary. And yes, I know I'm saying that. Hold on, I'm going to get to it. We're going to have some centralized intermediary say that anytime you can exchange the token for the car, right? That's it. This is where having directly backed, off-chain collateral tokens introduces some centrality risks, right? And this might be why you might want to not have an off-chain collateral asset that is directly backed, because you have to introduce some type of centrality. USDC is a perfect example, right? USDC is a stablecoin, represents dollar. It has a centralized intermediary, right? What you could also do is you could say, okay, well, I don't want my tokenized real-world asset to have a centralized intermediary. Ugh, that's gross. We're in Web3. I don't want to do that. So what you could say instead was, okay, I want to have my collateral be on-chain, and instead of me selling the token also sells the car, I'm just going to say me selling the token just sells me the price of the car. This is where you could have a synthetic car token, right? So you'd have your car, which is off-chain collateral. Your collateral is on-chain. You could use like ETH or whatever you want. And then you would just have like a Chainlink price feed that says, hey, the price of my Honda Civic is $10,000. At any time, you can exchange your token for $10,000 of ETH. Boom, you now have a synthetic car tokenized real world assets. And that is much easier to do and keep decentralized. So that's the approach that most tokenized real world assets projects take right now. However, to me, what's really, really cool, and what we're going to talk about here, is using something like Chainlink Functions to custody some assets, or maybe take photos or something like that, or take photos. What a specific example. To make your collateral off chain, while reducing the amount of centrality as much as possible, if not reducing all of it. And if people can do that, that is insanely powerful. So the reason I give this backstory here is because a lot of people talking about, oh, tokenized real world assets, blah, 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 blah. There is going to be a centralized component, and your job as engineers is, how do I reduce this as much as possible? So make sense? Any other questions here? Smash the like button. Yes. So secondary market off for Tesla. There could be a secondary market for Tesla too. Could Chainlink decentralize some of that centrality? Yes, they absolutely can. And that's what we're going to be talking about today. Phenomenal question. So the other example in this repo here is where we do that, where we try to reduce the centrality as much as possible. So if we go to SRC, there is this dTesla.sol. So what this dTesla does is, it basically, you have a user, you have some type of brokerage custody some actual Tesla token, and then you use a Chainlink function to check to see how much Tesla token is actually custodied, and then you can sell your Tesla token for the actual value of the Tesla stock. And whenever you sell your Tesla token, the broker will actually sell the Tesla stock as well. And to make this truly decentralized, you would just have several brokers doing this all at the same time. You lose a little bit of that margin, you lose a little bit of efficiency, but you increase the decentrality. So phenomenal question. Yes, with Oracle's Chainlink Functions is going to be the ticket to doing that. Could we borrow against the value of the vehicle with a token? So here's why tokenized real world assets are so cool. Yes, if you have a tokenized car, right, what you can do is you can take that token, you can stick it in a DeFi protocol, and you can take your car token and like borrow some other asset to like go leverage up on like your car or something. You can do a lot of crazy stuff. This is like certificates for gold bars, kind of, not owning the physical. Exactly. Yes. Spot on. There's a little bit of a caveat there, where this is one of the issues about tokenized real world assets. If you sell your tokenized car, it doesn't necessarily enforce that the car in the real world has to be sold. So you would need some type of mechanism to do that if that's the route you wanted to go. Or you could just say, hey, it doesn't matter. The tokenized car has the value of the car. I don't care about actually owning the car. I just want to deal with the finances of selling the car and stuff. And that's where a lot of that synthetic stuff that I was talking about works, or what we're going to show you. So there's a lot of different ways to do this. You would remove the payday loan, car, equity loan companies. This could help for sure. So that's kind of the backstory here. Like I said, we have video coming out on this. To me, Chainlink Functions is kind of this crazy unlock, and that's kind of what I want to go over in this video. Is kind of this crazy unlock because Chainlink Functions allows you to really do anything, like make API calls to anywhere. So like one of the things that I think is super cool, and I really want someone to build, because this could be a product like tomorrow, that would be super sick, is so you would have, so there's an issue with like lumber mills, for example, or farming, where you have to spend a lot of money up front to plant crops, wait for them to grow, and then you sell, when you harvest, and you make all your money at the end. The thing that sucks is that so much liquidity locked up waiting for these plants to grow, so much money up front. What would be sick is if you planted these things, you got a token for like your planted trees. For example, it was like lumber token, right? And what you do then is with Chainlink Functions, you basically tap into satellite imaging, checking to see, hey, are these trees actually growing? Do they actually exist? It periodically reports on the contract, hey, yep, they're existing. Here's kind of the pace they're existing at. Here's kind of how much we estimate their value is going to be. And you literally have like an interest accruing liquidity token on the future price of like crops or something like that. And like farmers basically can actually like have a DeFi asset that they can use for the future of their crops. Really freaking cool stuff. You can do this. Just like tapping into all these APIs, you can just do amazing stuff. Like that's just one idea that I think somebody should like go off and do like right now, because I think that that's like super, super sick and would actually help a lot of people like who have to lock up all this liquidity very early. In any case, I've already jabbered on for super long. Instead of normally I like to kind of do building walk-alongs, but it might actually make sense for me to just walk you through the repo, because building it from scratch might take a long time. So let me do this. I'm going to ask the comments here. Okay. You have 3 options. Okay. Number 1, we build a synthetic, decentralized, synthetic Tesla token. So it's a tokenized Tesla whose price will always be 1-to-1 with the actual price of the Tesla stock. This is going to use Chainlink price feeds. It's going to use ETH as collateral. It's going to be very resemblant of DAI. So that's option 1. Option 2, we do and option 1, we build that from scratch, because that one we can build in the 30. How many minutes do we have? 40 minutes left. 40 in the 40 minutes that we have left here. Option 2, we walk through this RWA creators repo with this dtesla.sol. Now, this one is way, way more sophisticated. How this one works is we actually purchase Tesla in a brokerage. We literally call an API using Chainlink Functions. We purchase Tesla, and every time we purchase Tesla, we mint a D Tesla token. So a tokenized Tesla token. And this is really freaking cool, because this token, instead of being synthetically kind of fake backed by Tesla, this one's actually backed by real Tesla tokens, very resemblant of USDC. And we literally show you the exact entire process of this. We're using the Alpaca broker, where we actually buy Tesla token, where we actually buy Tesla stock, and then we mint Tesla token based off of that. So that's option number 2, is where we walk through that repo. We'll walk through this repo. We'll show you that. Option 3 is we do this dTesla, but we build it from scratch as quickly as possible. And I'm going to tell you right now, building it in like 30 minutes it's going to be very difficult for me to answer any questions. Maybe I even scratched that one, but you can just watch me like panic build this as quickly as possible in 30 minutes. What would you all like to see? Okay, option 2, option 3. 2 is probably the best. How 3. You guys just want to see me like lose my mind. Okay, 3, 2. Nobody wants to see the synthetic token, I guess, huh? Okay, 2, 3. Okay, we're getting a little bit of back and forth between 2 and 3. Okay, 2 and 3. Someone's actually a masochist. There's no way I can do 2 and 3. 2, giving an overview will motivate us to take it from there. 2, 2, 2 for learning purposes. 2. Okay, I think 2 is the play here. What is the API? I will show you the API. All right, so we're going to go with 2, and this will give you all plenty of time to ask questions. For those of you who want number 3, I actually have a video of me actually building it, explaining why I'm making the design choices that I'm making, coming out on the Chainlink YouTube very soon. So stay tuned for that. We're going to go through number 2 right now because I think this is going to be really, really good and give you the lowdown here. So let me pull up my code here, and I'm going to flip screens in just a second here. Let me just make sure I have all my stuff. All right. 1 second. This is like what's really cool about this too is the fact that nobody's taking advantage of this right now. Yeah. So, okay. Oh, wait. Actually, sorry. Before, okay, cool. So I have my thing. I'm gonna, Sophie. I'm gonna switch screens in just a second. Not quite yet though. So before I flip screens, let me show you the API that we're working on, that we're going to be working with for this. So this is Alpaca. This is an API first trader, right? So I know I'm getting into trading. You never thought your boy Patrick would get into trading, but here we are. I used to work at a hedge fund, right? So of course I know all this shit. So here we are at this Alpaca API. So I've already signed up, already have everything in here. And here's how it works. So I'm on a paper trading account, but you could just very easily make this a real trading account, right? So this is resemblant of really any brokerage out there, right? So you open up, you could open up some brokerage position, you go buy your stocks, and this is where they are. With this, we can actually make API calls with Chainlink Functions from our smart contracts to buy or to sell tokens, which is crazy, right? And so this is a little bit centralized, obviously, because this, if we were to move this to like a real open, like live account, like we would be KYC'd and stuff. And this is where if you wanted to super decentralize this, you would just have several brokerages with several different KYC members and stuff. Like each Oracle would essentially be, a custody holder of the actual Tesla. But in here, in our paper trading account, and anybody can set one of these up to kind of test this out, and we have like some API keys and stuff that we set up with. We have purchased some Tesla. So it looks like market's open right now, so we could actually purchase more if we wanted to. We have purchased this much Tesla at this much Tesla. The market, we can see the market value, the cost basis. We can see that, oh, hey, look, our total cost, our total, we made some money. So if we had actually bought Tesla when I made my demo video, we would have made $11,000. Damn, what a mistake. What a mistake to not do that. So what we can do is we can go to our orders. Actually, no, not the orders. Where do I go? How do I buy stuff? And then this is one of the API keys that we're going to use. I don't care because it's just a paper trading account. Orders. I forget how to make an order. Where do I make a freaking order? And we get 100 grand of fake money. So this is all fake money. Where's my account positions? Make order. Oh, I have to do this. Oh, duh. I have to go to the actual asset. Okay, cool. So we're on Tesla here, and what we could do in our paper trading account, we could say, all right, how much cash do we have? We probably have enough cash to buy, 100 shares, and we'll make it good to cancel, review order, confirm order. Order's been created. If we go to our orders, we just put in this market buy order. It's kind of small at the bottom here. And orders. Looks like it hasn't been filled yet, which is fine. We'll go back to positions. It didn't go through, but that's fine. At some point it'll go through. But this is how you basically buy stocks on this. So we have this money in here. And now what we can do, Sophie, I'd love to switch over to my other screen. If you can pop this into the show. Thank you. Much obliged. What we can do now is I've got this huge repo already kind of set up. What you're going to want to do, if you want to follow along, if you want to go to that repo and actually play with it, you're going to want to first, actually, it says everything in the README that you want to do. Blah, blah, blah. You're going to need all this stuff installed: Git, Foundry, Node, NPM, and Dino. Dino is like another Node.js. You basically just want to get this set up by running make. So make is going to install all this stuff for you, all the Foundry stuff, all these packages, so that our tests work, so that our functions work, so that everything works. And what the heck? Oh, maybe I was playing with this. Or maybe I... All right, cool. Well, I had an issue. I might have to fix that later. It's fine. So we have everything. And in here, if we go to our functions folder, this is kind of the key to this whole repo here for working with the functions for working with Alpaca. So we have this these configs, these simulators, these sources, and this is like straight out of the Chainlink Functions documentation, right? So if you go to the functions documentation, this is how you're taught to get these all set up. We have this first function here. Excuse me, this first script, which is all JavaScript. I know, blasphemy coming from me writing JavaScript, where all we're doing is we're going to make this API call from the blockchain. So if we go to our dtesla.sol, we have this fulfill request function where what it does is whenever somebody wants to mint this this Tesla token, they first need to make a call saying, hey, do we have enough Tesla token in our brokerage? Okay. And so we call this mint request function, which makes the functions request, and then it returns with the amount of Tesla stock we actually have. And if we have enough money, it'll mint that money, right? It'll mint all the Tesla to that person, and then they can go sell it. They can go do whatever the hell they want with it, right? So in order to make that call in this dTesla, we have this request. Where's the request? Get request. Oh, I got to fix that. Come on, where's the send mint request function? And this kicks off a Chainlink Functions call. So this function right here, send mint request. What this does is it does a whole bunch of weird stuff, and it does some checks. But this function down here, this line is the line that sends a functions request. So it's going to emit an event. Chainlink node is going to go, oh my God, look, somebody wants to get access to our brokerage. It's going to go take the code that's living on chain, take this JavaScript code. This JavaScript code, we're literally going to stick this JavaScript code on chain, which is wild because it's going to stick this JavaScript code on chain. It's going to tell, hey, Chainlink node, execute this code. And then it's going to respond saying, hey, we have this bounce, right? So if we look in this code, all it's doing right now is this API call is just making a call to our Alpaca account. And it's going to say, here's how much money you have in the account. Based off of how much money you have, yes, you have enough Tesla stock to mint this synthetic Tesla or this directly backed Tesla token. So, and we can simulate how much money we have is if we can simulate calling this function by calling make simulate, which is just running npm run simulate. I'll even just do that. So if we do npm run simulate, we're running this alpaca balance function here, and it returns how much money we have in our account right now. So this is like with it's multiplied up with the zeros. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So in our paper trading account, we have $99,601 and in some change, right? As far as the Tesla goes. So then we can take that response, pop it into our smart contract, and boom. So let me just run the test suite. Oh, actually do have to download stuff. And the test suite is fun because Tesla test is base test. This test suite shows exactly like end to end what everything should look like. So we have this test can send mint request with Tesla bounce, where we call dtesla.send mint request, and it'll generate a request ID. But like the most important one is test, or one of the most important ones. It's going to be test Oracle can update portfolio, where we're going to testing the Chainlink functions can actually update the Tesla contract saying, hey, you have a portfolio balance. And then we have function test can mint after portfolio balance is set. We call this send mint request. This is us pretending to be the Chainlink Oracle to responding. And then it shows that, yes, we've indeed minted the Tesla token. So I have a weird version of Foundry installed. Sorry about that. I know I kind of ripped through this kind of quickly, but any questions so far? Oh, market is closed. Oh, okay. Market just closed. Well, I mean, it's paper trading, so it was a quick silly example. So I know I kind of ripped through all this really quickly. I'm glad that I didn't code this from scratch because that would have been impossible. Are there any questions so far? You just finished the ENV ENC step from your workshop earlier today. Excellent. Any questions so far? I can see all your comments. This works with commodities also. I am not sure. It might. This was just an example brokerage. You could use whatever you wanted. So yeah, Christopher, that would be a really sick project. Maybe you make a gold, right? A tokenized gold using Chainlink functions. That would be very cool. Can we use Alpaca on, say, country? Not sure. I don't know. I'm not sure what you're asking there. But the really cool thing about this whole thing is that we're literally putting JavaScript code on chain, and that's getting executed. Now, the redeem thing, once somebody says, hey, so the question, obviously, the biggest question for any of these tokenized stablecoins is how do they keep their value pegged to the real world asset, right? So in this example here, the real world asset is Tesla, right? So how do we make sure that the Tesla token always has the same value as the Tesla if we're directly backed? And this is where we have this JavaScript sell Tesla and send USDC. So in this Tesla smart contract, this is what makes it so cool. And somebody should actually, productionize this and build this. And this would be super sick. Is we have this send redeem request. And what this does is on chain, it sends a request to the brokerage to sell the Tesla for USDC, send it to the contract, and let me withdraw. So, like within like 5 minutes, you can sell actual Tesla for USDC. So it's not synthetic; it's like truly directly back to the asset, which is wild. And I'm like, somebody built like doing this demo project. I was like, holy shit, somebody should build this. This is going to be so cool. And this JavaScript lives on chain. And what it does when somebody hits that redeem request, they're saying, hey, I'm done with this Tesla token. Give me the money. Give me the USDC. What it does is first off, it sells. So these are the APIs here to sell the Tesla for dollars. So, for dollars, sell a Tesla for dollars. This is JavaScript that does that. Then with those dollars, buy USDC. So Alpaca supports certain cryptocurrencies. So buy USDC. Then this code sends the USDC back to this Tesla contract. And then once it's sent in here, where's the function? Oh, that's the mint. Where's the redeem function? Redeem. Once it's sent back here, the contract, the fulfill function will get called. The Oracle will call the fulfill function, and it will say user to withdrawal amount. It'll add the amount of USDC that was added. And then what they can do is they can then withdraw the USDC out of the contract. So wild. This is not something that exists today. This would be so freaking cool if this existed. And you could do this with anything. You could do this with Tesla. You could do this with commodities. You could do this with the lumber example that I gave before. You could do this with farmland. Like there are so many issues with so many projects that require so much liquidity to lock up. And this could allow you to make liquidity tokens for projects that take a long time, that only pay out late at the end. You could create a market for them, give these people a way to actually trade some money with having taken these huge risks up front. And the fact that this Tesla token can be liquidated pretty much right away using Chainlink Functions is absolutely wild. Okay, so now let's see these questions. This JavaScript is stored on the blockchain. Yes. So when you call these mint Tesla and redeem Tesla functions, the Chainlink nodes will actually read the JavaScript they're being told to execute off chain. So what's cool too is you can actually update the JavaScript. So like if instead we said, hey, you know what, USDC, not good enough, we want to do USDT, all you'd have to do is you'd update the JavaScript code on chain. So in this dtesla.sol contract, there is a state variable called mint source, two state variables, mint source and redeem source. So this mint source is a string, and it's literally JavaScript code. It's literally JavaScript code that lives on chain, checking the balances so that the token can actually get minted. And the redeem source is this code base that I showed here. So if you ever wanted to update these, boom, it's a storage variable. Boom, you update the JavaScript on chain. So it'd be really cool. Glad you're introducing this. Hey, glad to be here. like I said, we have some more videos coming out on this very soon. You guys are getting the sneak peek early. Any idea on how to build proof of ownership to verify the ownership of off-chain asset? Could be car, house, etc. That's a much, much harder question. There are ways that you could do something like that, but I'll be honest, that's a very difficult challenge. If you can solve that, you will probably make a lot of money. So, I mean, seriously. So when building something unique, where do we start? We need to get the JavaScript code working for API call and processing that info before touching the smart contract, right? Yeah, I'd probably start with the smart contract, to be honest. Why would I start with the smart contract? Because I want to see what code I even need. Like what do I need to touch? What parts of my system are going to be decentralized and what parts are going to be centralized? How do I reduce? I would start with the smart contract, to be honest. And then I would do the API. It is stored off chain, not stored on the blockchain. No, the JavaScript code is actually stored on chain, which is really cool. How can Chainlink proof of reserves enhance security for tokenized real world assets backed by off-chain collateral in DeFi? So Chainlink proof of reserves, great question. Is let's say you have some tokenized asset that's synthetic, right? Or, wrapped Bitcoin is actually my favorite example, right? For wrapped Bitcoin, you have a Chainlink proof of reserves that says, hey, there's actually 10 Bitcoin in this contract address, right? And a proof of reserves function could say, yep, there's actually 10 Bitcoin in this address. Therefore, we can mint 10 wrapped Bitcoins. Without the Chainlink proof of reserves, you're just kind of like, yeah, I hope the money's there, which is ridiculous. So Chainlink proof of reserves really, really, really powerful for a lot of these synthetic assets. I think proof of reserves is like probably the coolest thing ever. Chainlink proof of reserves for something like wrapped Bitcoin or like cross-chain wrapped native assets. How do parameters work? That JavaScript code just takes inputs dynamically from the contract. Yes. So that's a great question. So amount Tesla. So this amount Tesla is going to be the arguments from the so like this is going to sell Tesla, right? So amount Tesla and amount USDC. So in the D Tesla contract, when we call redeem, send redeem request, we have this amount Tesla parameter, and we pass this amount Tesla. We pass it as amount Tesla in USDC, and we set it as one of the, so we send both amount Tesla and amount Tesla in USDC. So we set these as arguments in the smart contract itself. And then in our code base, we have this args object that gets injected into our JavaScript that we can pull those arguments out of. Great question. Within stage of the hackathon, what do you mean? Oh, it's so amazing. Thanks for glad to hear that. Can we use a packet on any country? I don't know, but you can definitely sign up for a paper trading account in anywhere. So if you want to test this out anywhere, no problem. If you wanted to open a live account, they probably have restrictions on countries, but for a paper trading account, yeah, you can just open one up, start playing with it, and then just find somebody from when you want to go live, just find somebody from an acceptable country. This gets okay. Well, hold on. This does not get a stamp of approval, security approval. Okay, this is a demo code base. Okay, we do not audit the demo code bases. Yes, this could get the stamp of approval if somebody polished it up, but this is a demo code base purely for education purposes. Do not use this code base in production. I hope I don't have to say that. This code base in its current form does not get the Cypher security stamp of approval. Okay, but this architecture is great. This architecture is fine, just so long as you understand the risk, right? There is a centralization component, right? You're working with Chainlink Functions. You want to make sure your private keys are stored. There's a lot of other security stuff you need to keep in mind. I think I missed that part. Does your smart contract actually call a packet for quality available to mint? Does it simulate that interaction? It actually calls it. So great question, Raymond. So let me show you again. So when we send redeem, so this function here, Send redeem request. We have it set up that anybody can call it, but or sorry, not redeem. Send mint request. This is the only the owner of this contract can call this send mint request. And what it does is it'll this bit right here, this send request is actually going to call the Chainlink nodes to execute that balanced JavaScript. Okay. So it's going to say, hey, Chainlink nodes, how much Tesla do we have in our brokerage account? And the Chainlink nodes are going to go, oh, let me go check. And they're going to go run the JavaScript. And then they're going to respond with this mint fulfill request. And in here, it's like a bytes memory response. Out of the bytes memory response, we'll get the portfolio balance. And it's going to say, hey, you have $100,000 of Tesla. So we're going to go, oh, okay, cool. We have $100,000 worth of Tesla. Let's mint how much money that was requested. If we have enough, if we have enough Tesla collateral to mint, like if we have, if we have $100,000 of Tesla and someone was like, hey, can you mint $1 million of Tesla? The contract is going to reject it, right? So it only lets you mint amount of tokenized Tesla as you have collateral for. So yes, the Chainlink nodes actually execute this JavaScript and they respond based off of the results of the JavaScript, which is crazy. The video yours before the hackathon is over. I'm not in charge of the deployment, so I hope so. Excuse me, I'm not in charge of releasing the video, so I hope so. It's already filmed, it's done. Just it's going on somebody else's channel. So how do you deploy this project? Okay, I got to repeat. Don't deploy this. Okay, in its current state. It's for demo purposes. Demo. No, there's a demo code base. But in the makefile, if you wanted to demo, if you wanted to deploy this, we have a. Do we have a deploy script? Okay, so we have these deploy scripts in here. This is kind of the main thing that you want to deploy. So this is a Foundry deploy script. So it's like Forge. You can look up in the Foundry docs how to run deploy scripts. This would be like Forge, script, dtesla.sol, RPC, private key, blah, blah, all that stuff. But some of the input parameters are going to be this JavaScript. There's a number of other kind of config stuff you need to add, like your Chainlink Functions subscription ID, your mint source code, redeem source code. Each different chain has a different functions router, DON ID. You need a Tesla price feed, a USDC price feed. There's also some particular secret stuff that you need to do. We talk about pretty much all of this in the README. Yeah, we talk about pretty much all this in the README. So be sure to follow along with the README. If for this hackathon, you are using this as kind of like a template for what your project, you have a question, leave an issue on the repo, leave a pull request, let me know. Where is the JavaScript code called when inside the contract? What function? Okay, hopefully I showed that already. Not the demo, the project. Or the process. Oh, yeah. Hopefully soon. Hopefully it's deployed soon. Okay, show us in deploy testnet. How do you deploy JS? There's 7 minutes left. So on the Sepolia testnet, it's the same thing. Actually, I think I did just kind of explain that. So in this dtesla.sol, this alpaca mint source points to the alpaca code. And we basically call this Foundry bit here. String memory mint source equals vm.read file alpaca mint source. And then we take this mint source and we input it as a string to the contract. So like literally there's a variable called mint source in your smart contract with just JavaScript code. And you have to write a simulator. So this is my simulator code that simulates how the Chainlink node would respond, right? So when I wrote, sorry, that was some ZK Silk stuff. Make simulate. This is like simulating what the Chainlink node is going to do when it tries to simulate this. So hopefully that makes sense. Next, how do auditors confirm the legitimacy and precision of data? Oh, did I miss a question? Okay. the legitimacy and precision of data linked to RWAs within Chainlink Network. What actions are taken if there's a single auditor or centralized approach in place? Great question. So the first thing an auditor will do, they'll sniff out real quick, is that there's a centralized component, and that itself will already go in the audit report. Hey, there's a lot of trust on this centralized actor. Then what they have to do after that, though, is figure out to what degree that centrality is in there. What is it mitigated by? There's basically like they just have to do a deep dive on who this source is and how they're contributing. So something like this demo here, they would real easily call out, hey, huge reliance on this broker being honest. Boom. That's it. That's pretty much it. And this is why a lot of people choose to go the synthetic route, because they go, hey, it's a reliance on Chainlink price feeds. Those are decentralized. This is good to go. So like I said, there are trade-offs here. The advantage of this demo as it is that the tokenized asset is actually backed by the actual asset, which is wild and not something that we see, and it opens up whole lots of other doors. The synthetic asset is a route that is pretty common today, but is also, really badass. Is there a reason only JavaScript can be used for functions? At the moment, it's because that is the only support that they have built. That's it. So they're working on Python. They're working on other stuff. Can you show the Alpaca JavaScript code again? Oh, okay. So this is this is just the simulator code, but the balance code is this Alpaca balance. So this gets the balance, and at the top we have this like looking for keys bit. That's it. But then we really just make a single API call with our keys, and then this return is important because this is what is going to get posted on chain. So we're going to return the portfolio balance. We do a little bit of Web2 fixed point math to make it a nice Web3 fixed point math bit here to make it like a nice Web3 number. But that's it. Is the Alpaca account linked to each user who performs the operation? How is the link made? The Alpaca keys. Great question. So this API call just calls get account, and it gets your account based off of your keys. So your keys are unique to you. The keys that I'm using in this project are like dummy keys, so like whatever. But that's how. Question off topic slightly. Architecturally, can you recommend on-chain and off-chain API gateway management system Kong for like embedding finance? This seems like a lot of orchestration for devs. Can you recommend on-chain and off-chain API gateway management system Kong for like embedded finance? This seems like a lot of orchestration for devs. Not sure. I'm not sure what you mean. I'm not sure what you mean by that. I'm working on proof of ownership. Want to work with it? Oh, okay, cool. I had worked on the fractionalized NFT product before dealing with actual real estate properties. You can own a fraction of the property and trade it on the marketplace. Can it be converted to RWAs? That is an tokenized RWA, right? The question is, how is that fractionalized NFT enforced, right? Is it just a, hey, trust us, bro? That's not good, right? Like, that's not good enough. You got it. Okay, great. Good to hear. Is there a GUI or a tool in Web3 DevOps tool that can make deployments easier? It just seems like there's a lot of config in this that might be easier to manage if you use some nice GUI. Yeah, so this one, so as we get more advanced here with a lot of this off-chain stuff, pretty much everything in here is stuff that nobody's doing and nobody's done before. So because nobody's done it before, it's harder to use. This is actually really good feedback for the functions team. I agree. Maybe like a GUI tool that would make this easier to deploy. Yeah, 100% agreed. So we should give that feedback to the functions team. Yep. Any other questions before I jump off here? Chainlink Functions has a playground. Chainlink Functions has a playground. Yep. Be sure to use that. It's very, very fun. Very cool. Hopefully you all learned a lot. I know this was, there's a lot to take in here. Like I said, we have some videos doing the walkthrough coming out very soon. So you can view these and watch me build in real time exactly how these get set up. And yeah, really hope to see some. Really glad to hear this open up a new world of possibilities. Yeah, like literally. Okay, so just let me stop real quick, and then I will shut up. What functions unlocks is stuff that we have not seen in Web3. A lot of people in Web3 try to go, oh, cool. Look, Uniswap was successful. Let me copy Uniswap. Oh, look, USDC is successful. Let me copy USDC. Before Uniswap was Uniswap, before USDC was USDC, there was nothing. Somebody had to make it first. So this is like your opportunity to make a lot of crazy financial products first. Good luck. Have fun. You know, when you become multimillionaires or whatever, when you build these amazing protocols, be sure to hit up Cyphren for your security review, and good luck at the hackathon.
Awesome. Thank you so much, Patrick. That was so insightful. I hope all of you have taken notes. You can definitely use all of this knowledge into one of our hackathon tracks, financial services. We are definitely looking forward to see some projects on the RWAs topic. So super excited for that. And again, if you have any questions, feel free to send them our way. We'll definitely make sure Patrick gets them. And yeah, good luck. Keep hacking and see you later today because we still have one more workshop for today. Thanks, everyone.
Bye, all.